On Monday, June 29th, 2026, the most powerful machine ever built by human hands, the Large Hadron Collider over at CERN, literally went dark. Now officially, it's just a routine upgrade, something they call long shutdown number 3. But, if you look really closely at the data and the history of this massive 27-kilometer ring of superconducting magnets, a much, much more provocative question emerges, one that might actually affect the very fabric of the reality you and I are experiencing right now. Could the immense, staggering energies generated inside this machine have inadvertently bent time, or perhaps even reality itself? Welcome to this explainer. Today we're going to completely look past all the internet rumors and focus strictly on the published physics, the documented anomalies, and the profound questions surrounding the LHC.
Okay, let's dive into this by looking at where this whole conversation actually started. And I want to be super clear right up front. This is absolutely not some fringe internet conspiracy theory. It actually starts with a real, peer-reviewed 2007 paper published by two mathematical physicists, Irina Arefova and Igor Volovich. The title is striking in its directness, right? Time Machine at the LHC. Published a full year before the machine even turned on, these highly respected scientists at the Steklov Mathematical Institute weren't writing science fiction at all. They were engaging in very real, highly complex theoretical physics.
Section 1. Why study time loops? The quantum gravity connection. So, you might be wondering, why were serious physicists studying time loops in the first place? Well, they were hunting for the absolute holy grail of physics, quantum gravity. They desperately wanted to know if the universe's fundamental rules start to warp at extreme energies. And this directly brings us to the closed time-like curve. Listen, this is not a metaphor. It is a literal mathematical solution to Einstein's field equations where a path through spacetime literally loops back on itself. In plain language, it's a time machine. Not, a DeLorean with a steering wheel, but a natural physical consequence of extreme energy concentrated in a tiny space. The scientific community engaged in a very serious debate over this paper, arguing over whether the LHC could inadvertently create these curves, before they kind of just quietly moved on as the machine powered up. To really grasp why that idea wasn't just laughed right out of the room, we kind of have to contrast our everyday macro reality with quantum reality. In our world, right, effects follow causes. The past is fixed. But at the quantum level, things get incredibly weird. Think of it like reading the final chapter of a book, and the very act of you reading it physically rewrites the beginning of the story. John Wheeler's famous 1978 delayed choice experiment, which, by the way, has been experimentally confirmed time and again, shows that a particle can behave as if its future is already decided. Essentially, a measurement you make right now can physically determine how a particle behaved in the past. This is known as retrocausality, and it is a proven fact of quantum mechanics. Now, I want you to scale that up to 13 tera electron volts. That is the staggering, literal Big Bang-level collision energy the LHC was eventually upgraded to reach. The LHC doesn't just look at single, isolated particles. It smashes trillions of them together. So the really uncomfortable question some researchers started asking was this: what exactly happens when you scale up that proven quantum retrocausality to this completely unprecedented magnitude? Are you amplifying the effect? Are you somehow creating conditions where the future actually leaks into the past, not just for a single subatomic particle, but on a much larger scale? Section 2. Anomalies at CERN and what the data shows. Now look, when you run a machine this unbelievably complex, you're definitely going to have data issues, right? Bugs, calibration errors, hardware limitations, that's totally standard in particle physics. But if you dig into the forums where CERN watchers and self-described former technicians gather, you find these unverified whistleblower accounts that are just eerily consistent. We're reporting this completely impartially. These are not peer-reviewed claims, but they are fascinating. One anonymous technician actually claimed high-energy collision instruments were recording timestamps that simply didn't align. They were describing data appearing in the stream fractions of a second before the collision that was supposed to produce it had even occurred. Believe it or not, theoretical physicists actually have a very specific term for exactly what those anonymous forum posters were describing. It's called retrocausally modified data. It literally means information that has changed because the event was influenced by something in its future. While the official explanation for those data gaps remains, standard technical glitches, these unverified accounts paint a picture that perfectly matches the theoretical warnings from that 2007 paper about causality breaking down. And that leads us perfectly to one of the most celebrated moments in modern physics, the 2012 discovery of the Higgs boson. absolutely a monumental achievement. But did you know the announcement was actually delayed for months? That delay was officially due to the need for intense data verification. And during that time, there were some serious whispers in the physics community about statistical anomalies. There were strange data points in there that just simply didn't fit the standard clean narrative of the Higgs discovery. So the crucial point is what those anomalies actually were. Researchers noted these weird excess events that clustered at a very specific energy range. Coincidentally, this exact range matches theoretical predictions for exotic particles called Higgs singlets. If these hypothetical particles actually exist, they have a completely mind-bending property. They would act as their own antiparticle and could, theoretically, travel backward through the temporal dimension. These excess events were noted in a lot of internal discussions and then, well, kind of just quietly set aside as the whole world celebrated the main Higgs discovery. Section 3. The Cultural Ripple and Reality Bleed. Now, we aren't here to validate internet culture as absolute scientific fact, but the correlation drawn by some of these theorists is frankly fascinating. Just consider the timeline for a second. In 2007, the Time Machine paper is published. In 2008, the LHC officially turns on. Just 1 year later, in 2009, paranormal researcher Fiona Broome coins the term Mandela Effect to describe mass shared false memories. Then skip to 2015, the LHC restarts with its energy nearly double to 13 TeV. That exact same year, the Mandela Effect basically explodes across the internet, with people noticing massive numbers of changing memories. Theorists call this reality bleed, suggesting that those high-energy collisions were subtly altering the quantum field of our reality. And this brilliantly illustrates what millions of people claim to be experiencing with this reality bleed. Widespread examples include vividly remembering Nelson Mandela dying in prison in the 80s, even though he actually became president in the 90s, or remembering Star Wars C-3PO as entirely solid gold, rather than having that one silver leg, or Dolly's missing braces in the James Bond film Moonraker, which so many people swear used to be there. Theorists suggest these aren't just instances of bad memory, but residual memories of an older timeline, preserved in our minds even as reality updated around us due to that quantum interference. Adding a really eerie, highly symbolic layer to all of this is the massive bronze statue standing right outside CERN's headquarters. It's Shiva Nataraja, the Hindu lord of time, cycles, and destruction, frozen mid-dance. It was actually a gift from India back in 2004. With the LHC now completely shut down, some theorists pose a rather unsettling thought. The dance of creation and causality changes doesn't necessarily stop just because the music or the machine stops. If a quantum bell was rung, you can't necessarily unring it just by pulling the plug. Section 4. The next big collider and scaling up reality. Because here's the thing. CERN isn't just turning off the lights and walking away. Planning is already well underway for the Future Circular Collider, or the FCC, slated for the mid-2040s. To truly grasp what they are building here, just consider the sheer physical scale. The LHC is an already staggering 27 kilometers in circumference. The proposed FCC will be an unbelievable 91 kilometers around. It's going to be so massively huge that its subterranean tunnel will literally pass underneath 3 different European countries. Let's move to and see how this builds on everything we've just been discussing. The FCC isn't just bigger in size. It's explicitly designed to hit 3 times the peak energy of the LHC, and its primary scientific focus is exactly what we've been talking about this whole time: dark matter and specifically TeV gravity. They are explicitly targeting the exact same theoretical quantum gravity effects that Araveva and Volovich warned could produce closed time-light curves way back in 2007. I mean, think about it. If the LHC caused minor reality bleeds, what on earth happens when you multiply that power by 3? Section 5. The ultimate unknown and what it means to be inside the system. This brings us to a really chilling epistemological nightmare. When we try to test the fabric of reality, we're testing it from inside the system. We aren't objective observers looking at a terrarium through a safe glass wall. We are literally inside the terrarium, which leaves us with an incredibly provocative question. If reality actually was altered by the LHC, how would we even know? If causality itself shifted, our memories, our history books, our digital records, they would all simply update to match the new timeline. We would be completely, utterly blind to the fact that anything changed at all, save for perhaps a vague, collective feeling that things used to be different. As the LHC goes quiet and the massive FCC looms on the horizon, it's a profound thought to carry with you. Thank you for joining me for this explainer. Keep questioning and stay curious.